This program is brought to you by the Vegetarian Society of Hawaii, a nonprofit organization dedicated to sharing with the community the many benefits of a vegetarian diet. Free monthly meetings include vegetarian experts found locally and on the mainland, quick and easy cooking demonstrations, and healthful and delicious food samples. Members enjoy an informative quarterly newsletter, social activities, and discounts at many vegetarian-friendly restaurants and health food stores. For an application, call 944-8344. That's 944-8344. Or visit our website at www.vsh.org. vsh.org.
Could everyone please find a seat now and we'll get started. I'd like to welcome you all to the monthly public lecture sponsored by the Vegetarian Society of Hawaii. I hope by the end of this evening you'll all be inspired to become members of the Vegetarian Society if you're not. The board members are here to answer any of your questions after the meeting, and I believe we have refreshments over in the kitchen also.
They've asked me to talk about this proclamation that was signed by Mayor Jeremy Harris, and a few of us went to his office recently. I'd like to read just 3 sections of this. You'll get the gist of it. Office of the Mayor, City and County of Honolulu Proclamation. Whereas pollution and the depletion of our natural resources, fueled by consumer demands, are taking an increasingly devastating toll on the environment for this and future generations. And whereas many citizens of Honolulu, including members of the Vegetarian Society of Hawaii, have adopted a vegetarian diet out of respect for the environment and encourage others to do the same, and whereas each vegetarian saves an acre of trees every year and helps preserve our precious water supplies, now therefore I, Jeremy Harris, Mayor of the City and County of Honolulu, do hereby proclaim April 21st, 2002 as Go Vegetarian for the Environment Day. You can still go vegetarian if you're just visiting us tonight. If you're not already a vegetarian, you can still go vegetarian and save the environment. That was very nice of him to give this to us.
Yes. Thank you, Helen. And I particularly want to thank Jim Brown, who again is behind the literature table, because it was at Jim's instigation that this proclamation came about. So, yes, thank you, Jim. We're delighted to have with us Dr. Edward Fujimoto, who will be discussing the group of chemicals known as dioxins. He'll describe what they are and how they get into our food supply, and he'll also suggest ways that we can protect ourselves from these dangerous chemicals. Dr. Fujimoto was born in Hawaii, but has spent much of his adult life in other areas. He received his master's and doctorate degrees in public health from Loma Linda University in California and is a certified health education specialist. He's had a chance to observe firsthand several diverse cultures, having been the director of health education programs in Georgia, Tokyo, and Guam. He's currently the Health Promotion Wellness Manager and Clinical Preventive Care and Lifestyle Medicine Specialist at Castle Medical Center in Kailua. Dr. Fujimoto specializes in health education, preventive care, nutrition, health promotion, and lifestyle medicine. His research areas include weight management, smoking cessation, and vegetarian nutrition. Dr. Fujimoto is the author of many publications, including books such as Weight Management for People Who Want to Change Themselves, Vegetarian Diet for Quality Breastfeeding, and Total Natural Food Diet Health Method. In 1995, Dr. Fujimoto was listed in Who's Who in the World. Ladies and gentlemen, please welcome Dr. Edward Fujimoto.
Thank you very much. I was back there listening to the introduction. I was thinking, man, I want to listen to the speaker. Sounds so good. And then I got up here, I realized it was about me. And tonight, I think I'm in a very good environment here. A lot of people who have the same interest and same practice as far as diet is concerned or health is concerned. I don't have to put on my Kevlar vest when I speak about this, where in some places I almost feel like I have to. But tonight we'll be talking about a subject that all of us should be aware of. And if you aren't, tonight you will be totally aware of it, and you will be given some practical methods of solving this seemingly insurmountable problem. And it'll be partially within your power to do something to protect yourself. If you look at the title here, Dioxin, the chemical terrorist in your food. Now, all of us are fully aware of what a terrorist is now, right? Well, let me tell you that dioxin is a terrorist, and you will understand why I call it a terrorist. It acts just like a terrorist. You know, if you had an army that attacked a country, you would have a battle at the front, but when you have a terrorist, it gets in and you don't know it's there until it works. It does something. And so this is what dioxin acts like. What is dioxin? This is the formula for dioxin. You can see here that it has 4 chlorines. So you call it tetrachloral. You have 2 benzenes, dibenzodioxin. It's got these oxygen links in the center. So this is dioxin. It's tetrachloral dibenzodioxin. Now, there's several other dioxins with different numbers of chlorine, but this is the most common. Now, here's what dioxin is. There's a group of 75 chlorinated hydrocarbon chemicals. In other words, it has carbon, hydrogen, chlorine, and oxygen. So that's why you call it chlorinated hydrocarbon. It's a byproduct of industrial processes, chemical manufacturing, garbage incineration, and combustion of leaded gasoline. Now, if you look at this here, we are many, many decades into the use of and the practice of these 3 items. And so you can see that we are totally exposed to dioxin, some of us more than others. And tonight I hope we can make a difference in the way we live, so that those that come after us won't have as much dioxin to worry about as we did. Well, where does dioxin come from? It comes from pesticides. Be careful when you use pesticides. Almost all of them have dioxins in it. Industrial chemicals. There are over 70,000 chemicals on the market. Okay, so a lot of industrial chemicals. Industrial processes, when you produce things, dioxin is a waste product or byproduct. And the incineration processes. How many of you in your lifetime burned garbage? When you burn garbage, I think there's a 90% chance you introduce dioxin to the environment. Most of us aren't aware of that, but that's the biggest source of dioxin. PCB and electrical transformers and capacitors, these are banned, but it still persists in the environment. And plastic products. Now, how many of you use plastic products? There's lots of it out there, you know. Yeah, like this, you know, and like this, right? You use these things? Okay. That's where these plastic products is very convenient. I just noticed there's a cup of water down there in a paper cup. I almost grabbed the wrong one. Okay. And then food products. That's right. Dioxin is in the food products too. Now, we know that dioxin is a problem because we noticed certain things that happened in the environment as far as the wildlife is concerned. And some of these problems that we noticed made us wonder, now, why did it happen? For example, abnormal blood hormone levels. We noticed, for example, some of the endangered species, mountain lion and so forth, the panther in Florida, they find out that the male panthers have more female hormone than male hormone now. And the female panthers have more male hormone than female hormone. It's turned upside down. And reduced fertility in fish and birds. And when you look at birds, the shells of the eggs are so thin-shelled that they don't survive. Altered sexual behavior. Female gulls nesting with other female gulls. This is in California. This is something that's happening. modified immune system. We see that we have certain parts of the immune system are overworking, other parts are not responding. Problems such as masculinization of females in the wildlife, hermaphroditic fish in the Great Lakes, you can't tell if they're male or female. We have feminization of males. Florida alligators have reduced testes and penis size. We have undescended testicles. Not the type of talk you want to do at in a social gathering here, but that's the kind of stuff that's happening here. Cancers of female and male reproductive tracts, malformed fallopian tubes, uterus, and cervix, and altered bone density and structure. And all of these items are related to hormones. And that's where we find the problem here. Dioxin is toxic, okay? 2,3,7,8 tetrachlorodibenzyl dioxin is the most studied form of dioxin. It's toxic. How toxic is it? 1/1,000,000th of a gram kills a guinea pig. We're going to deal with things like 1/1,000,000th and 1/1,000,000th of a gram amounts tonight. But I'll show you that it has an effect on us. It is a potent carcinogen. It is an endocrine disrupting chemical. Endocrine disrupting chemical, it affects our hormone system. It's associated with decreased immunity. It's neurotoxic. It changes behavior, learning, memory. Okay, and it can cause birth defects. Now, there are a lot of stuff here, right? A lot of things it can do. And we're talking about very, very small amounts. The history of major dioxin human exposure. Now, we're talking about very small amounts, but let's look how much dioxin was thrown into the environment here. 20 million gallons of Agent Orange, aerial sprayed over 6 million acres in Vietnam as a defoliant. Dioxin. Amazing, isn't it? And then, we had a chemical factory explosion in Italy in 1976. Times Beach, Missouri. I don't know if you remember this. They took this oil, waste oil, that had a lot of dioxin in it, and to keep the dust down and to keep the roads paved, they sprayed us all over the ground there. And when they found out it had dioxin, it was, how many years later? 12 years later? It's amazing. And all these people got exposed, and the town was completely banned. It's still an off-limits place. And Love Canal, New York, toxic landfill made into housing developed in 1953, and families were evacuated in 1978. So we have human problems that we've observed also. There's some other things that happen in Texas we'll talk about later on. Dioxin causes cancer, and we knew this back in 1985 that the EPA actually considered that this is one of the chemicals that has the greatest threat as far as cancer is concerned. However, industry protested vigorously, and they suppressed this report, so it didn't come out the way it should be. 1991, 1994, EPA reassessed dioxin cancer risk potential as 1 in 1,000. That's pretty high, 1 in 1,000. But the report still didn't come out because of industrial pressure. In 2001, EPA was forced to come out with a report, and they toned it down and says it causes cancer in animals. Interesting, isn't it? And it should be regulated. Well, that's a lot of pressure they had to overcome, but we know that the mechanism by which it causes cancer, it suppresses a checkpoint protein that increases the instability of chromosomes. It actually causes DNA bending, and so it brings about a problem with carcinogenesis and also mutations. And so we know the mechanism and why it works that way. Dioxin also causes immune suppression. It reduces antibody production, reduces immunoglobulins, reduces T lymphocytes, suppresses killer cell activity, so you're more susceptible to viruses and cancer, increased infection rates, increased cancer rates, and it causes chloracne, a skin problem. And this is my first exposure to dioxin. I first became aware of it in Japan because there was a community right close to where my hospital was, and the children there had chloracne. We couldn't figure out what was happening. They were sent to a dermatologist, and he couldn't figure out what was happening. And we found out there was this big incinerator that was upwind from them, and this incinerator was spewing out dioxin. And in Japan, they burn almost everything because they don't have much land area to fill. But anyway, that's my first exposure to dioxin. Dioxin problems are so pronounced in Japan that it is the strictest country as far as dioxin is concerned, and almost everybody in Japan is aware of dioxin. They know where it comes from and how to prevent it, and they're very environmentally strict on this, whereas here in Hawaii, we're very lax. Now, the body, in order to stay alive, here you have the brain, you have the musculoskeletal system, you have the digestive system. To keep this alive and to keep everything functioning right, you have a hormone system. The hormone system has precise control over everything. The endocrine system, okay? Now, it's a network of glands that produce hormones. They release them into the bloodstream in very small quantities as chemical messengers to change the organ performance. And it maintains a delicate balance of systems in the body. These very small amounts act in a precise time and manner so that you can control your system. Well, the endocrine system is composed of many, many endocrine glands. These are some of them. Hypothalamus, pituitary, thyroid. A lot of these are so small, very, very small, like the size of the tip of a little finger type of thing. That's how small these endocrine glands are. And they put out the hormones at the right time, on the right command. All these systems here, I think most of us are aware of this one here, the pancreas, right? This has to do with sugar control and blood sugar control. You have beta cells that put out insulin. You have the alpha cells that put out glucagon. And let me show you how a hormone works, okay? Here you can see the black line is blood sugar. You eat and your blood sugar goes up. As your blood sugar goes up, your pancreas senses the blood sugar rising, and immediately it puts out insulin, and so your plasma insulin goes up, and immediately it takes control of the situation, brings your blood glucose down. When you eat again, it goes back again, the insulin comes out at the right time. It has a precise control. If it didn't do that, your blood sugar would stay high. It works like that, okay? Now, if you have too much of a hormone, you have a problem. If you have too little of a hormone, you have a problem. The action of endogenous hormones, the hormones that your body produces, is controlled very precisely. And it does that by binding, okay? It may cause the hormone to bind to a globulin or something to keep it inactive. And then when it needs to act, it cleaves it off and it becomes an active hormone. For example, sex hormone binding globulin. And it can also break the hormone down by enzymes. That's what happens to insulin. It breaks it down so it quits working after it's done its job. And then it can control the availability of receptors. A lot of these hormones need receptors to act. Insulin is one of them. And so it controls it by that. Now, if you have small quantities of these things, and you have a small increase in the quantities, it can cause a problem. For example, Cushing's disease, Cushing's syndrome, overproduction of cortisol produced by the adrenal gland results in bone pain, depression, fungal infections, high blood pressure, increased facial hair, muscle wasting, moon face appearance, thinning of skin, weakness, weight gain, just from one hormone being too much or too little. Okay, this is too much here. So you can see where hormones are real important. The precise amount is very important. If it's not precise, you'll have problems. Now, estrogen is an example of negative effects of excess quantity. Some people think, well, if you have a little bit more, it's better. But no, that's not true. Estrogen is implicated in breast cancer. Inadequate estrogen is implicated in postmenopausal problems. And adequate estrogen provides protection from heart disease and bone fractures. Now, dioxin is an endocrine disruptor. Okay, it's an endocrine disruptor. It disrupts this system. It acts just like the endogenous hormone, acts to activate or inactivate at the wrong time. It blocks the normal hormone activity, triggers the wrong response at the wrong time or the right response at the wrong time. So everything is going to be out of whack. That's what dioxins do, okay? Now, there are two types of endogenous hormones. I want you to know this because you need to know why dioxin does what it does. You have two types, the protein hormone The protein hormone, remember, these hormones have to go into the cell, okay, to act. The protein hormones do not go into the cell. They require receptors on the cell membrane to produce an effect in the cell. You have steroid hormones. Most of you have heard of steroids, right? That's the stuff that makes that, all the muscle and stuff. Well, it's one type anyway, the testosterone type of thing. But here you have the steroid hormone. It goes through the cell membrane directly into the cell without requiring surface receptors, okay? So there are two types. If you know this and you tell your doctor that, he'll be surprised, Say, wow, you know a lot. I forgot about that. That's what I say. The protein type hormones, these are the ones that require receptors. The characteristics, insoluble in the lipid cell membrane. In other words, they don't dissolve in fat. To produce the effect, it requires a receptor on the cell membrane. It requires a messenger molecule in the cell to trigger the effect, and are larger than steroid hormones. That's why they have receptors on the outside. Steroid hormones are lipophilic, which means they dissolve in fat so they can go right through the lipid cell membrane. See, the membranes of cells are made out of fat, so it passes very easily through there, and it attaches the receptors inside the cell to trigger that effect, and it's very small, so it can go right through the membrane. So that's the steroid hormones. Now, I know that a picture is worth 1,000 words. In this case, it's probably worth 10,000 words. It'll help you understand this. Here's a protein type hormone. It comes in, attaches to the receptor. When it attaches the receptor, messenger goes up there, and the messenger brings in signal to the nucleus, and the hormone has an effect. That's a protein type. Now, here's a steroid. Steroid hormone, it goes right through the wall, it goes directly inside to the receptor and affects the cell. You see the difference? Now, how does a dioxin molecule work? Here's the dioxin endocrine disruptor. Okay, here is the steroid hormone, here's the endocrine disruptor. They look alike, right? Just different color? That's because that color is different, that's all. And here is how it goes. It goes right through the membrane. It goes in and it latches onto receptors. The good hormone has no chance to latch onto a receptor. Now, you remember I mentioned earlier that when a hormone acts and its job is done, it usually is cleaved off by an enzyme. But when you have one of these endocrine disruptors, it doesn't cleave off. It stays on the receptor, so the receptor is no longer usable by that hormone, so it keeps on acting and acting and acting, never stops. You understand? That's what an endocrine disruptor does. Now, the characteristic of an endocrine disruptor is lipophilic, soluble in fat, exists in very small quantities. We're talking about billions and trillions of a gram. Acts in non-monotonic dose response. You want, what in the world does that mean? I'll explain later. Accumulates, it's stored in fatty tissue. So all of us have fatty tissue. Some have more than others. Well, that has nothing to do with it, but you still have fatty tissue. And it's stored there. It's persistent. You know how persistent it is? The half-life of dioxins is measured in decades. This is very important. Very long half-life. And very persistent. Doesn't leave the body except in very unusual circumstances. For example, if you breastfeed, you pass it on in your breast milk. Or if you burn your fat up, you might be able to get rid of some dioxin. But most of it is in the fat. If you go in a lot of stress, the dioxin comes out and makes you sick maybe. You know what I mean? The dioxin might act. So you have that type of thing. It's cumulative in action. You have hundreds and hundreds and hundreds of dioxin-type endocrine disruptors. And each one has a small effect. Each effect is cumulative. Each one acts differently, but they all add together and they have a bigger effect. Very scary. Now, it's not only dioxin. Over 70,000 chemicals worldwide. Few have been tested because of sheer numbers and because of the small, minuscule quantities that have effects. There's no way to test all this. There's no way to test all this. And what do you do when you have a cumulative effect? Mixtures. How do you test the effect of that? The chemical groups that disrupt hormones, phthalates, these are plasticizers. Do you remember the teething rings that you gave to your baby? That's got phthalates in it. That's why it's banned in Germany now and parts of Europe. All that soft plastic stuff that feels so cozy and good, and all those toys, that's all got phthalates in it. Everything that's plastic that's soft has got phthalates in it. Alkophenols, these are detergents. Bisphenol A, lacquer in the cans. Organochlorine pesticides, the stuff that we put on roses and stuff like that, Biphenyls, these are PCBs and dioxin. And fungicides, antioxidants, etc. All of these disrupt hormones. And there are more groups than these, but these are the main ones. What happens is, in our body, we have a defensive system. And when you have a chemical that comes in, if it comes in a very small amount, the liver doesn't even sense it's there. And so the liver that's supposed to scrub out all these poisons doesn't act very promptly, and it gets by the defenses. And so a large amount goes into fat cells and gets stored there, and when it comes out of the caves, like in Afghanistan, they come out and they start bombarding the cells with the hormone effect at the wrong time. That's why I call it a terrorist chemical in your food. Here it is, the non-monotonic dose. Oftentimes we think that, okay, we do these tests on animals, and you give a certain dose to the animal which is higher than you would give to a human being. Because we don't care, we do care if the animal dies, but these researchers don't. And so what they do, they can extrapolate the effect. In other words, the more you have, the more effect. However, dioxins are not like that. They're non-monotonic. You see that you reduce the dose and the effect goes up. That's non-monotonic. That's why it's a problem. There's no way to determine when this thing will have its effect. It's a very, very curious chemical. Now here's a monotonic type of thing, and people can understand this. The more you smoke, your risk for lung cancer, that's a monotonic response, okay? But dioxins don't have that. It's a non-monotonic. It's hard to predict. You can't extrapolate. You have to test it in that particular situation directly to say that it does that. Understand? That's why it's so difficult to test. The effects are additive and cumulative. A single substance may have a small effect. Hundreds of thousands of substances are existent, and each of the small effects sum up to a very significant effect. The effect may be synergistic. In other words, you don't just sum it up. The final effect may be greater than a sum. 1 plus 1 might end up to be 3 or 4. So you cannot test this very easily when you have a mixture. Therefore, determining safety of mixtures becomes almost impossible. Now, we are bombarded with these contaminants. These are 2 one-year-old infants. One is breastfed, the other is bottle-fed. This is a gas chromatograph of the baby urine, which shows how much of these chemicals are present, and each peak here represents PCB or pesticides. Okay, you can see how many peaks they have, how many pesticides, how many chemicals are present in a one-year-old infant. Bottle fed on the bottom here, you can see where the peaks are different, right? The amount is proportional to the height of the peak, but the number of chemicals in there, phenomenal. And that's a one-year-old. Now, you're more than 30 times more than 1-year-old, maybe. I don't know. Some of us are. 60 times anyway. But anyway, you can see where I'd have a whole bunch more if I just didn't do anything. And so that's what our talk is all about from here on. What are problems seen in humans? Sperm counts are falling. Not the sky. Sperm counts are falling. And they thought this was an anomaly. It was not a real, it wasn't a valid result. But, the 61 studies that came out in 1992, people started attacking it and so forth, but they checked it and checked it from different directions, and the more they checked, the more valid it became. And it's true. For example, U.S. sperm count is 50% lower in that period, okay? 1938 to 1990. European sperm count is even greater, decline. And in non-Western countries, there's no trend. Depends on who you are, where you are, what you did. But in the Western countries, it's very definite. Now, the estrogen link. estrogen level is vital to normal male fertility, specifically sperm count. Now, these dioxins have an estrogenic effect. So, you can kind of link those two together. Why dioxins may be causing this problem. Here are some other problems. Increasing rates of testicular cancers in men. Of course, it only happens in men. But here you see it's tripled in Denmark. And you see that it's 2 to 4 times greater in England, Nordic and Baltic countries, Australia, New Zealand, and the U.S. It's the number 1 cancer in men aged 15 to 34 in Scotland. It's increasing. And the reason for this is dioxin, or these endocrine disruptors. Here are some other problems. Developmental problems. Cryptorchidism, undescended testes, clear increase, reduced testes and penis size, hypospadias. This is not a subject I want to really describe, but it's something you have to know here. You know, your urethra on your penis, usually it comes out the tip, but now you have this stuff being dislocated. It ends up in the middle, on the bottom, or on the side, or someplace. And so you no longer have a normal way of urinating. And its prevalence has doubled between 1968 to 1993. Demasculinization is also occurring. You see some problems here in human beings, right? Now, in females, breast cancer is higher. One of the causes is this, okay? Increased risk of lupus, fibrocystic breast disease, polycystic ovary, endometriosis, uterine fibroids, pelvic inflammatory disease. Some of you have experienced this or are experiencing it. These very difficult diseases in females is linked very strongly to dioxin. In fact, the government is now in a full-blown research to confirm this. So it is something that you have to consider and you have to reckon with. Females have shortened menstrual cycles, which means that they go through more cycles in the same amount of time, puts them at higher risk, shorter ovulatory lifespan. So it causes problems. It delays getting pregnant. That's what these things do. Early puberty, premature therapy. Now, we've got situations where, for example, there is a building site, a home development, housing development in Texas that was built over a chemical dump. Chemical dump was closed decades earlier. Had a lot of chemicals in there, including dioxin. They built over this thing. The little girls that were born there, they were menstruating at 6. That's one case. There's worse than that. In Puerto Rico, because of this type of problem, because they eat so much chicken there, and the chicken had all these chemicals in it, these little girls were entering their menstrual cycle at age 3. Now you think about that. This is very strange, right? That's premature lethality. And then you have masculinization. Okay, here's some more things. Losses in motor coordination, short-term memory, verbal skills, psychomotor development, and IQ drops, all measured here. It also causes problems in behavior. This dioxin can be called one of the rage hormones that was discovered in Japan. That's why some of these children in junior high school, they can't control the temper and they'll pull a knife and kill people. You've seen that, right? They'll go and hit someone over the head with a baseball bat. They can't control the tempers. Now, determinants of the effect. Now, these things are important. When you're exposed is important. When in your hormone cycle were you exposed? The timing is very, very crucial. How long you're exposed, the combined exposure, what did you get exposed to, what else did you have exposure to? Dose of exposure, was it for 1 hour, or was it for 1 week, or was it for 10 years? Age at which exposure occurred. The very, very highly susceptible period is, of course, when the baby is in the uterus, the first 3 months. Unfortunately, the mother is already exposed to this, and that's where the exposure starts, in the uterus. Now, there's 3 sources of hormones that we're exposed to. One of the hormones is the endogenous stuff we're talking about, the stuff that the body produces. That's an endogenous hormone. They're produced in our bodies by the endocrine system. There are two more hormones that we're exposed to. The second one is the natural hormones found in foods. For example, phytoestrogens, isoflavones, lignans, found in, things like soybeans and strawberries and things like that, Those are the natural hormones. And the third hormone, the synthetic hormones. That's where these things come in. The dioxin, PCB, BHA, DDT, dieldrin, phthalates, bisphenols, and other chemicals. These are the synthetic hormones. So 3 hormones are in the environment and we get exposed to. Now, that doesn't mean that, you can't do anything about it now. Because there are distinct differences in the 3 hormones. And I want you to notice this. Very, very important here. You see a quantity. Here's a quantity. This is a half-life. 3 different hormones. Endogenous, very small amount, right? Very short half-life. The half-life is measured in minutes. Some are measured in seconds. Very short. The endogenous ones act and they quit acting. They're precise. Now you look at the natural hormones, the stuff that you have in your food. The quantities are huge, right? Very huge. But look at the half-life. The half-life is measured in minutes or hours. Now these are very important. Okay, now look at the synthetic hormone now. That's what the problem is. Very small amount, and they act for decades. The half-life is decades. Now, if you look at that, that's what the problem is, because the body controls hormones by cutting its effect. The quantity isn't as important as how long it acts. Now, both the endogenous and natural hormones have a very short half-life because the body has a way of stopping the effect at the right time. But with a synthetic hormone, it cannot do that. Now, that's a problem. Now, where do we get our hormone disruptors from? In raw food? Contamination of food. I'm talking how do we get into our body, right? Packaging, preparation. We'll talk about a little later here. Other, like paints, plastics, detergents, solvents, pesticides, so forth. Some of you don't realize it, but I don't know how many of you have pets at home. Dogs? Okay, you have a flea shampoo they use on dog, right? Now, when you shampoo the dog, the first week, when you pet the dog, all that stuff gets on your hand. Now, for adults, it might not be as bad as for little children. That is an exposure to dioxins. Interesting. You should wash your hands after you pet the dog. For more reason than dioxins, of course. Right? Now, some people don't, and so that's a problem right there. Now, talk about packaging and preparation. Plastics are used so much in packaging. It's so convenient that everything's in plastic. However, if the plastic is containing food that has a high fat content, it's at a high temperature, it's there for a long time, the food will absorb the plastics that are leaching out of the container, and it contains phthalates and dioxins. And then you eat that and you put it into your system. We developed a very convenient device called a microwave oven, right? And so when you microwave something, what do? You put it in a plastic container and you put saran wrap over it. Now that's the worst thing you can do. That's the highest source of dioxin contamination by plastic, heating plastic in the microwave. You've got to stop doing that. You have to warm things in a microwave using glass or ceramic. If you want to use saran wrap, make sure it doesn't touch the food and it's on there just to cover it, and you take it off as soon as it's done, because it'll contaminate it. That's been shown. How do we reduce our exposures? Avoid foods that are high sources. What are high sources? We'll talk about it later on. It'll be very clear. Reduce intake of fats and oils. Why? Because these endocrine disruptors are lipophilic. They're found in fat, and they might be absorbed into the fat that you eat. And so if you avoid that, you avoid a major source of dioxin. Avoid cooking, heating, microwaving, storing in plastics. That's why I say sometimes I might have to wear a Kevlar vest, especially when I walk in front of one of those vendors that sells a lot of these things, Tupperware stuff, you know. But, you know, it's kind of scary there. But in Japan, they have produced all these lightweight glass containers or ceramic containers for microwaving because they're much more concerned than we are. Use pesticide-free foods if possible. Don't use pesticides carelessly. No kidding, man. This stuff gets into the environment, it doesn't leave. Don't burn plastics. Let me repeat that. Don't ever burn plastics. Don't ever burn plastics. It gets into the air and it goes and contaminates everything around there. You've got areas around the country where we had incineration processes, and the ground there is so contaminated, you have to take the ground off and you have to haul it off and put new dirt there because it's contaminated. You can't get rid of it. And you should drink only clean water. We're fortunate here in Hawaii. You know, we've got clean water here. Now, let me show you something that's very, very interesting here. Okay, start from the bottom here. This is nanograms per cubic meter, okay? Vinyl chloride, you burn vinyl chloride, you see how much dioxins come out, right? You burn polyethylene, a little bit less, right? Polystyrene, less. Okay, now you put the two together, polyethylene and vinyl chloride, and you see how much, it's not additive. There's more coming out, right? Okay, here you burn newspaper. Very little coming out. You soak the newspaper into salt water. You dry the newspaper out, and you burn it. Wow. Why? Because salt contains chlorine. And when you incinerate it, it combines it into a dioxin chemical, which is one of the reasons why you have to be careful about incinerating things. Now, that's as high as if you burned newspapers with vinyl chloride. Interesting, right? That's how strange this chemical is and how we produce it. The concentration of these pollutants is different at various levels in the environment, which will make you draw a conclusion from this. For example, Clear Lake, California, you take the lake water and it has that much parts per million of DDT, okay? You know where Clear Lake is? Okay, very good lake, right? Okay, very little contamination. Now, you look at the phytoplankton in that water, and it concentrated up to 5 ppm. And then you take the herbivorous fish that eat the plankton, and it concentrates it up to 40 to 300. And then you take the carnivorous fish that eat the herbivorous fish, and it concentrates up to 2,500. You better know what kind of fish you eat if you're going to eat fish. But my solution here is to just stay away from that part of the spectrum there. I think it's safer because you don't know where your fish came from. Here are two different types of people here, a vegetarian and a non-vegetarian. And you look at the breast milk from these two sisters who are actually genetically the same. It's just that their diet is different. You take the breast milk and analyze it for different contaminants here. You see the difference here? Where did it come from? From the diet, right? Okay, now that's one conclusion you can draw there. Now you can expand that conclusion to something else later on here. Here's a dioxin intake of Japanese in Japan, okay? Wherever you go, doesn't matter where you go, in the metropolis, in the towns, rural country, rural areas, the amount that you get is the same. The total amount is the same. Because of the food that is all over the place, you eat the same food. And so you get it. Doesn't matter where you live. In other words, it's not the air, it's not the type of environment you live, it's what you put into your body that makes a whole lot of difference. For example, here is where dioxin is accumulated in the tissue, in the body of an animal, and you can extrapolate this to your body also. Fat, see how much is there? Liver, muscle, do you eat muscle? That's what meat is, okay? Muscle. It's muscle of a dead carcass of an animal or something, right? That's muscle. Lungs, kidneys, brains, spleen, blood. Hopefully you don't need much of this stuff, lung, kidney, brain, spleen, blood, but you can see where A lot of stuff that people think is healthy, like liver. Liver is not a healthy food. It's the garbage dump of the body. That's where all the dioxin is accumulated. And some people think they eat more, and if it's raw, it's even healthier. Let me tell you, it's a risk that they'll pay for later on. Just think about that. Now, dioxin food sources in Japan, the highest source is fish because they eat a lot of fish. Okay? It's because they eat a lot of fish. But their meat and eggs, very high. Dairy products, high too. Very little from vegetables and seaweed and so forth. From fruits, very little. Now, you can draw a conclusion from that too, right? Okay, it'll just keep on building here. Now, dioxin intake of U.S. population. Where did it get it from? The highest source is what? Right. The muscle tissue of a dead cow. That's where it's from. Dairy products next. Milk, chicken, pork, fish, egg. Very little from the air, soil, and water. You see what I mean? If you're worried about the environment, think about the environment you put into your body. It's much more important. Concentration of phthalates in food. Now, this is going to be a sore point for a lot of people, but it's the truth, so I just have to tell you what the truth is. The highest amount is in cheese. Why? Because it's packaged, it's aged, it's put in wax and aged for years, and all that stuff goes into the cheese. And so you eat the cheese and you eat the phthalates, which are disruptors, hormone disruptors. Butter is a high source too. High fat there. You have hamburgers and fish, chicken, liver, eggs, milk. There was a shopping survey done all over the United States, and they took all different kinds of foods in different places, and they measured the amount of dioxin that was there. Is this disturbing here? What is the highest amount? Freshwater fish. Why is that? One reason is that the waters are all contaminated, okay? The second reason is that a lot of these freshwater fish are actually farmed. And because they're farmed, they get all this contaminated stuff fed to them. Butter is up here too, and ice cream is up here. I'm sorry, but ice cream is up there. Okay. Ocean fish is here too. And then, very interestingly, in this particular study, they very, very conveniently took what a vegan eats and they measured it. And look at that. Interesting, right? What a difference. What a difference. And so, here's another conclusion you can draw, right? It's a very, very good conclusion you can draw there. Now, the conclusion of the matter is, eat a low-fat, high-fiber diet. Because fats absorb dioxins and all these endocrine disruptors. Why high-fiber? Because from our research, we know that fiber is one of the few things that can get rid of dioxin from your body. Very interesting. Avoid food from the higher levels of the food chain, dairy products, meat, fish, shellfish, poultry. Eat foods as close as possible to organic and natural states. The less you prepare it, the less chance of contamination. That's what it is, actually. Do not prepare or store in plastic receptacles. I want to add one thing more on here. When I talk about this low-fat, high-fiber diet, we know that some of the phytoestrogens and phytochemicals that we find in a lot of the vegetables, fruits, nuts, grains, actually will block the effect of the endocrine disrupting synthetic chemicals. That has been shown, especially for things like resveratrol, stuff that's found in grapes, things like fat in fruits. It'll actually block the action of the dioxin so that it won't act even if it's in your body. So, you have to have more of those and less of the others. What are we talking about? We're talking about more fruits, vegetables. Not bad, Okay? Things like this. It's not bad food. It's protective. It has less contamination, less dioxin that will enter your system. And these things will protect you from getting the effect of dioxin. Fruits. Isn't that marvelous? Is your mouth watering? Let me confirm that, I'll tell you, the food that you're going to provide tonight is good. How do I know that? And it's healthy. It's good for you. How do I know that? Because I already ate it. And I'm here, right? You see how full of energy I am? It's good. It's very delicious. And it's completely the way I've explained it here. Grains? Good, right? Beans and all these things here. Squashes. A lot of color there. These are good for you. They will block the synthetic chemicals that are already present in your body. Not bad, is it? Very good. Now there's this here. It's no use incinerating dead carcasses in your kitchen anymore. You shouldn't incinerate anything anymore. You should bury it. That's what they do with garbage now. You have to bury it. If you burn it, you produce dioxins. That's what you have to do. Instead of that, you should replace it with something that's better. That's better, right? I suggest that. This is much better for you than anything else that was on the plate before you. That's the end of my talk. And I hope that you can draw some conclusions from this. Thank you. Any questions? Yes, right here. Yes. Her question is, does fasting help you get rid of dioxins? Now, the answer to that is very difficult, but it's either yes or no, or both. It's both. Because when you reduce your intake and you fast, you burn fat. When you burn fat, your dioxins that are stored in the fat will be released. You have to do something with that. That's why you have to have good food to block that. So you have to have your good food to block that off. Otherwise, it'll start acting in your body at the wrong place. Understand? But the thing we have to do is make sure that fat stores don't get bigger and bigger, because then when you do that, you just increase your dioxin bank, and you don't want to do that. So it's good to cut down on fat. Yes. Now, what is the effect of cooking on dioxin? It doesn't change it. Oh, that's a good question. Why is dioxin standing out among the 70,000 chemicals that were mentioned there? The reason for that is because dioxin was the one that came up first, and now the EPA has come up with a list that goes on and on and on, and it's about 150 now, and they're testing it slowly, but there's so many that you can't test it, and the amounts are so small that it's very difficult. So I think that answers the question there, right? Now, okay, back there. It's in the chemicals we use. Not only dioxin, some of the other endocrine disrupting hormones are in the chemicals we use. And if that's so, then we have to make sure we don't use very much. Now, there's some things that have been banned. Some of the insecticides have been banned because of that. But there's a whole bunch more that they have to go through and see what they're going to do with that. So we have to take care of ourselves here. Okay? Yes. Because if you use a lot of fiber, your gallbladder will put out the fats that it actually excretes from the gallbladder some of the fats, and that goes into your large intestine, and your fibers are there. It'll absorb to it and take it out of the system. That's one of the reasons why it can work. The same reason why you have sequestering cholesterol drugs and fiber works on cholesterol. Same type of mechanism there. Okay, the question is, these chemical products that you buy, what kind of names are we talking about? And I have a list here. Afterwards I can show you the list there. There's a lot of chemicals there, and it'll be kind of unnerving. The way you have to use some of these things anyway. Some of the detergents you have to use, so the things that you have to use, but you have to minimize the amount that you get exposed to it. Okay, that's a very good question. Now, if you eat vegetables that are sprayed, what do you do to get rid of the chemicals, right? Now, there are a lot of ways you can do it. You can wash it off with the right type of detergent. They have some that are totally contaminating type of detergent. The other thing that I recommend is to take powdered charcoal powder. Take a tablespoon of that, put it in the water, and then you swish your vegetables in there, it'll absorb a lot of the chemicals that are contaminating it, and you throw the water away. Powdered activated charcoal. Okay? The question was, since we know that some of these things like DES causes problems, and this dioxin, all these endocrine disrupting hormones that are steroid type will actually mimic that and cause problems like that. Can we link some of the gender problems that we have to the chemical? And I said, yes, we can. And that's been shown, okay? That's the reason why I was going to emphasize is I didn't, a good name for this, it's a gender bender chemical. It does. And so, we're in this environment that we created, and now we have to live with it. Now, we're all contaminated. Some of us will get the effect in a behavioral sense. Some will have it in a different sense, like in cancer. We're all affected, okay? So everybody's affected. Now, we can't say that, okay, they're worse than us type of thing. No, we're all the same. We've got to make sure that we protect ourselves as much as possible from the effect of this, because it's serious. It's a social problem. Okay, this became almost like a political type of conclusion here, but it's true. We have to work together on this. Because what happens is it causes it at a certain age in life, usually in the uterus, and at that point it's already affected. Okay, so that's one of the reasons, I think. Do I recommend a raw food diet? Not always. We live in the United States, and you can live with a raw food diet here, but I dare anybody to go to the Southeast Asia or the Philippines or any place like that and eat a raw food diet. You'll die from food poisoning in 2 weeks. So, there are certain places you can and certain places you can't. Now, we've got to be very commonsensical about this whole thing, and certain foods you need to be able to digest it, and so sometimes running it through some heat makes a lot of difference as far as absorption is concerned. So I'm not going to say that raw food is the only way to eat. No. We have to look at the whole situation. So we ran out of time, and I think you ran out of questions. Thank you very much.
Very good. Very good. Just a moment. Thank you very much, Dr. Fujimoto. There was a remarkable amount of good science and detailed information, and Down to Earth has provided refreshments which are available right now in the kitchen. And thank you again very much, Dr. Fujimoto, who's not going away, and so come ask him some more questions. Good night, everybody.
This program is brought to you by the Vegetarian Society of Hawaii, a nonprofit organization dedicated to sharing with the community the many benefits of a vegetarian diet. 3 monthly meetings include vegetarian experts found locally and on the mainland, quick and easy cooking demonstrations, and healthful and delicious food samples. Members enjoy an informative quarterly newsletter, social activities, and discounts at many vegetarian-friendly restaurants and health food stores. For an application, call 944-8344. That's 944-8344. Or visit our website at www.vsh.org. vsh.org.